Let's discuss a question from strength of materials. Basically, we have a cantilever beam and a moment m is applied at the end in an anti-clockwise direction, and we need to find out what is the vertical deflection. Now remember that a given coordinate system is given, so because in the answers you have pluses and minus, so we need to, like, if it is positive in the vertical downwards, then it is plus, and if it is above, it's negative. Now because of this moment, obviously at the built-in end where it is fixed, there will not be any deformation, and because of this moment, remember the movement is not clockwise, it's anti-clockwise, so there will be a deflection something like this, right? And this has got to be negative, but what is the magnitude we need to find out. Okay, so what we do is we use our uh, integration method, double integration method. We write the deflection of beams equation. Remember that in this equation with the minus sign, m is equal to minus ei by d square. In this equation, if m is sagging, then we consider as positive in this moment, and m is hogging, so it's considered as negative. So sagging means if you have a moment kind of a this, you take an element of the beam, and on both sides if you have something like this, then it is sagging. And sagging mostly happens in a when you have a vertically downward forces in a simply supported beams, whereas hogging is kind of a where the moment is like this, where the top fibers are in tension and the bottom fibers are in compression, whereas in sagging the top fibers are in compression. So this is basically a sagging moment, okay, and that's why we take m positive here. So if you take a section, so at a distance x, okay, the moment everywhere is m because it's a pure bending problem. You take a right side part of the beam, and this is m, so this also has to be m because there's no other forces. So m is constant everywhere, okay, so we can write, and m is positive, that's why we are adding plus m, so effectively nothing changes in this equation. And positive because it's a sagging moment, top fibers are in compression. This equation is derived keeping these sign conventions in mind, okay. So whenever you are using this equation, you have to keep this in mind, and depending on the sign of m, let's say if m is sagging, you have to just use the value of m, and if m is hogging, you have to just use the negative, okay. Had it m being the clockwise, then you would have used minus m, okay. So nothing changes here, you have to just use it now. So double integration method, so first we integrate it one time, so minus m by ei is constant, so x plus c1 is your dy by dx. Now we integrate another time and we write it here, which is minus m by ei x square by x square by 2a plus c1x plus c2 is equal to y. Now at the built-in end we know that slope is 0, okay, because there is a moment reaction movement, and that doesn't allow the slope. So at x is equal to 0, your y dash is 0 as well as your deflection is 0. So we use these two equations to get these two constants. So first, if I substitute x 0, dy by dx is 0, y dash is 0, so c1 is 0 by first equation. And then when I use the second equation with y 0, at x 0, y is also 0. So when I use the second equation, this is 0, c1 is already 0, and so c2 is also 0. So we get c1 c2 both 0, and so if I substitute back in the first equation, in this equation, or in fact in this equation, because we are interested in the deflection, so minus m by 2 ei x square is equal to y. Now we need the maximum deflection, obviously that happens at x equal to L, and that is minus L square by 2ei. Now the sign represents, that's what the beauty of this equation is, that because all the signs have been taken care at the beginning, so this will give you whether the deflection is positive or negative. Now deflection is negative, it means it's upwards, okay, because this equation goes with this sign convention plus with this coordinate system. So because if y we got negative minus, so it means the deflection is upwards, so that's a sense check, and deflection because of this movement has to be upwards. So we are on the right track. Answer is D, minus m L square by 2ei. Thank you.